Hello students, let us begin the third chapter, that is data modeling using the entity relationship model. This is the outline whatever we are going to see in the particular chapter. We will start with overview of database design process. There are two main activities involved in the development of a database design. First one is database design and the second one is application design. And whatever the chapter we are going to see, in this chapter we are going to focus only on the database design part. That is to design the conceptual schema for a database application. And regarding the second part, that's application design, we will not see in this particular chapter. That's actually a part of the software engineering part. We will see overall database design process over here. We have at the top a mini world. Mini world is a world wherein we are going to concentrate on a particular topic. Either it might be the university database. We want to have so many databases wherein we can develop application for university database, or it might be a banking system, or it might be a healthcare system. So here we are going to concentrate only on a particular topic. So for that reason we say it's a mini world. Then we have requirements collection and analysis. We have seen in the software engineering, right? Whenever we want to develop anything, the first and foremost thing is requirement collection and analysis. While we are going to collect the requirement from the customers or the stakeholders, we have to separate it out, right? Which are the functional requirement, which are the non-functional requirement, all these things, right? So that is the first and foremost thing that we are going to have in any application development. So the first thing is requirements collection and analysis. Once the requirements have been collected, we have to go for analysis of that, right? While we are analyzing, we have to separate the things like these are the function requirements and these are the data requirements, right? So here we have functional analysis. After the function requirements, we have functional analysis. Whatever the functionality that have to be incorporated in the application, that is being discussed in this function analysis part. Then here we have at the right we have conceptual design. Right here we are going to design in a such a way that we'll be making use of high level data model for designing this conceptual design, wherein we are going to concentrate on a data requirement part, right? Then we have a logical design wherein we go for deploying the things. Whatever the conceptual design we have with us, we will try to implement it out, and we are going to create the schema of the database that we are going to implement. Then we have at the bottom a physical design wherein we are going to study like what kind of indexing we are going to use, and how the accessing of the data is being done, and where the data will be stored. So that is regarding the physical design, right? So here we are making out a difference, that is DBMS independent part and the DBMS specific part. The top line, the dotted line, you can see the separation, wherein at the top we have some part which is database independent. Whatever might be the DBMS we are going to use, it is independent. Like functionalities are going to remain same, right? Whether you implement it by considering the DBMS like Oracle or MySQL, whatever it might be, the functionality will remain same. But when we are going to write application programs, and when we are deciding like what kind of accessing we are going to make use of, where the data is going to be stored, so that is a part which is DBMS specific one, right? Then we have application program design. If you want to access the information that is stored in a particular database, we require a front end, right? That is being implemented in the application program design. Once the design is done, then we go for actually implementing the application programs. So that is a transaction implementation. Let us consider an example of company database, right? We need to create a database schema design based on the following requirements of the company database. Okay, when we want to build any application of database, first we consult a stakeholders. Stakeholders will be giving their own consent, and based on this we will be developing the application. Here we want to build a company database. The company is organized into departments, right? We have a company which is having divided itself into various departments. Each department has a name, number, and an employee who manages the department. Each department has its own name, department number is unique, and employee who is the manager of the particular department. We can store that information, right? We keep track of start date of the department manager, that is when he has taken as a charge as a manager of the particular department, and a department may have several locations, right? This department might be having its offices in multiple locations. Then we have each department controls a number of projects. Each department controls multiple number of projects, and each project has a unique name. Whatever might be the project we are going to have, it will be having its own unique name, right? Then unique number is being assigned to a particular project and is located at a single location. If there is a project going on in Bangalore, it will be only in one place. It will not be having its office in Mysore or some other location. Then we store each employee's social security number, address, salary, gender, and birth date. Right? We are going to create a table, that is employee table, wherein we are going to store the information of an employee in terms of social security number, which is a unique thing, then address of a person, salary, then gender, then birth date. Each employee works for one department but may work on several projects. Whatever employee we are going to have over here, he'll be working only for one department at the max, and other thing is he might be working for multiple projects. We keep track of number of hours per week that an employee currently works on each project. Okay, he will be working on multiple projects, so we need to keep a track for one project, for a particular project, for how many hours he is working on. Then we also keep track of direct supervisor of each employee. For each employee, there will be a direct supervisor. That information is also stored in a particular table. Then each employee may have a number of dependents, right? Employee will be having the dependent, that is their family members like mother or father or daughter, wife or son. They might be dependent on this particular employee. So that information we are going to store it in a separate table, that is a dependent table. Let us see some of the concepts of ER model. The first thing is entity. What do you mean by entity? Entities are specific objects or things in the mini world that are represented in the database, right? Here we can give the example like employee John Smith, then research department, then we have product X is a project name. So this is an entity. Entities are specific objects or things in the mini world that are represented in the database. Then we have attributes. What do you mean by attribute? Attributes are the properties which we make use for defining an entity. We want to define a employee, right? Employee is designated as, like, there will be a name for a employee. Then we are going to give some SSN number, which is a unique, like Aadhaar card number which we have in India, right? So a social security number. Then employee will be having his own address, right? Gender, birth date. So these are the things which are explaining a particular employee. Then we have a specific entity will have a value for each of its attributes. Whatever the attributes we are going to have in a table, for a particular attribute we are going to give some values. For example, an employee entity may have name is equal to John Smith, SSN is equal to 1 2 3 4 5 6 7 8 9, address is equal to something. Then we have sex or gender equal to male, birth date, right? So this is the value which we have assigned for the particular attributes, and each attribute has a value set or the data type associated with the each attribute: integer, string, subrange, enumerated type. So these are all the data types which we are going to use for the various attributes. Now let us discuss regarding the various types of attributes. First one is a simple attribute. What do you mean by simple attribute? Each entity has a single atomic value for the attribute. For example, SSN or a gender, right? For a particular person, we are going to have only one number. Like in India, we have Aadhaar card, right? Aadhaar card, for each person we have only single Aadhaar card number, right? So that is a simple attribute. Then we have composite attribute. The attribute may be composed of several components. For example, when we write our address, how we are going to write our address? Let us start from apartment number, then house number, then street in which we are going to reside, what is the state, city, then state, zip code, then country, all these things. This is the way in which address is defined, right? So address is subdivided into all this uh, subparts. Or name, okay, a name of a person name is consisting of first name, middle name, last name, right? Then composition may form a hierarchy where some components are themselves composite. So this is regarding the composite attributes. Then we have multi-valued. Multi-valued attribute is an attribute wherein an entity may have multiple values for that attribute. For example, color of a car. Okay, we can see color of a car. We might be having some car which is having full black color, white color, red color, all these things, right? But apart from that, there might be some cars which are having multicolors, right? Some part is painted black and some part is painted white, right? So this is regarding the multi-valued, and multi-valued attributes are represented with curly braces or the flower bracket. And we can see the previous degree of a student, right? If a person is having multiple degrees, right, then we can again take it in within a curly braces. In general, composite and multi-valued attributes may be nested arbitrarily to any number of levels, although this is rare. If you consider example of a previous degree of a student, right, it is both multi-valued as well as composite, right? If it is both multi-valued and composite, how we are going to denote it? We will be having a outer layer which is previous degree, which is having a curly braces, right? Here we have a composite attribute as well as a multi-valued attribute, right, which is a previous degree, which is having like a student might be having multiple degrees. Then if you want to describe a particular degree, then we can have subfields: in which college he had studied, in which year he had passed out, and what's the name of a degree, and in which field he has done a particular specialization. Multiple previous degrees can exist, and each has subcomponent attributes like college, year, degree, and field. This is an example of a composite attribute: address, right? Address is divided into street address, cities, state, zip. Then street address is again divided into number, street number, name of a street, apartment number. Then entity types and the key attribute. Entities with the same basic attributes are grouped or typed into an entity type. For example, if we have multiple employees working in an organization, we can have everyone's information in a single table, that is employee. If we have list of projects, then we can store it in a same table, that is a project table. An attribute of an entity type for which each entity must have a unique value is called a key attribute of the entity type. For example, SSN of an employee, which is a key attribute and which is unique attribute. A key attribute may be again a composite. Sometimes what's going to happen is we are going to club together two attributes and we are going to call it as a key attribute, and key attribute is underlined. Okay, an entity type may have more than one keys also sometimes. If you consider a vehicle, either it is a car or a scooter, right, we'll be having two kind of things which are going to differentiate from one vehicle to another. One is the RTO registration number, right, which is a unique one, and apart from that, the people who are going to develop or who are going to manufacture a particular bike or a car, they will be giving a unique number, right? So vehicle identification number we call it as. So with this, in this particular case, a car, we have two different keys, right, which is different from each other, and each key is underlined. If you are having a primary key in a table, we are going to underline it. Now we'll see how actually we are going to display a entity type. In ER diagrams, an entity type is displayed in a rectangular box. Attributes are displayed in ovals, and each attribute is connected to its entity type. Components of a composite attributes are connected to the oval representing the composite attribute, which we can see in the next slide. Each key attribute is underlined as I explained. If there is any primary key, we are going to underline that one. Then multivariate attributes displayed in a double ovals. You can consider this example. If we have a car entity type, wherein we have um, attributes like year, model, then color, make, right? This is nothing but attribute values. Apart from that, we can see color we have double circled that. What is the meaning of that? It's a multi-valid attribute. Then we can see a registration attribute which is having again sub branches, right? Which is a composite attribute which is having state and number as the sub attributes in a attribute. uh, a B figure, which is an example of entity set with three entities. You can see a car is having a attribute like registration, and registration is having a attribute like number and state. Then we have vehicle ID as another one attribute, then make, model, year. Then we have color which is a multiple or multi-valued attribute. So we have represented with the curly braces. Then we can see car 1, right? ABC 123 Texas. What it is? It's a registration number. Apart from that, we have vehicle ID as TK 629. Then we have make, right? Ford Mustang is a make. Then model convertible, year 2004. Then the color of the car is red and black, right? So this is a instance, or we call it as a tuple. Entity set. What do you mean by entity set? Each entity type will have a collection of entities stored in the database, and it is called as entity set. You can consider the B uh, figure B, right? If we combine three things, the car 1, car 2, car 3 information, then it becomes a entity set. And entity set is the current state of the entities of that type that are stored in the database. You can say this is the current state of a database. We have taken three cars and we have stored their information in a database, right? Now we'll see initial design of entity types for the company database schema. Here we have department, project, employee, and dependent. So these are the four entity types we have considered, and their initial design and attributes are shown in this particular figure, right? We have department entity type, project entity type, employee entity type, and the dependent entity type. In the department entity type, we have locations as a multi-value attribute, right? Then we have department name and number as the key values in that. Then we have project entity type, wherein again the name and number is the key value in that. Then we have employee data type, employee entity type, wherein we have name as a composite attribute, then works one as a multi-value attribute, right? And SSN as the key attribute. For that reason, we have underlined that SSN. Then we have dependent attribute, wherein we have the normal attributes, right? Attributes are represented with the oval, like relationship, birth date. These are the example of a attribute. Then refining the initial design by introducing the relationship. In this, what we have is we have considered department as one table, project as another one table, employee as another table, and dependent as other table. And we have not shown any connection between those tables, but there exists a connection between the various things, and we call it as relationship. ER model has three things. One is entity, another one is attribute, and third one is relationship. But in this diagram, we have shown only entities like department entity, project entity, employee entity, and dependent entity. And apart from that, we have shown the various attributes like locations, name, number, manager start date for the department. And for the project, we have attributes like location, name, number, controlling department, right? Like this, we have explained only the entities and its attribute, but relationship is missing over there. Now, in the next slide, we can see the relationships. A relationship relates two or more distinct entities with a specific meaning. For example, employee John Smith works on the product X project, or employee Franklin Ong manages the research department. So you can see there is a connection between the two entity types. If you see the first example, there is a relationship between employee and a project, right? That is, employee John Smith works on product X project. Then we have second example wherein employee Franklin Ong, he manages the research department. So there is a relationship between employee and department in the second example. In first example, we have a relationship between employee and project. Then relationships of the same type are grouped or typed into the relationship type. Like if there are multiple works on relationship, we can have it in a same table, that is works on. Then um, the degree of relationship type is the number of participating entity types. If you consider example, um, like first example, employee John Smith works on product X. So there are two entity types. One is employee, another one is project. So we say that the works on is an example for binary relationship. Apart from that, we have Franklin Ong manages the research department. Again, the manager's relationship is a binary because it's in between employee and department. This is a relationship instance of the works for. That is, it's a n is to 1 relationship between employee and department because we have a constraint. What is the constraint? Here we have employee entity type and department entity type, and works for is the relationship type. Each employee works for any of the department, but the constraint over here is if he is working for department, if employee E1 is working for department D1, he cannot work for department D2, right? This is a constraint we have. So the relationship is n is to 1 because n number of people can work for one department, but it is not vice versa. That is, one person cannot work for more than one department. So this relationship is n is to 1 relationship. This is an example of m is to n relationship because when we gave the requirement for the database designers, what is the requirement we have given? We have given a requirement that is m number of employees can work for n number of projects. That is, if employee E1 is working for project P1, it is not restricted that he should not work for any other projects. You can consider example of employee E2. He is working for project P1 as well as he is working for project P4. In the similar way, E3 is working for project P2 as well as project P3 as well as project P4. So this is a relationship which tells us it's an kind of m is to n relationship, right? Then we have relationship type versus relationship set. What do you mean by relationship type? Relationship type is nothing but is a schema description of the relationship. It identifies the relationship name and the participating entity types, and it also identifies certain relationship constraints. When we have a relationship type with us, it's nothing but schema of the relationship. Apart from that, it explains which are the uh, entity types that are being engaged in this particular relationship type and what is the name of a relationship, and also it explains what are the constraints like n is to 1 then m is to n. So these are the constraints. Then we have relationship set. The current set of relationship instances represented in the database is an example of relationship set. Then we have the current state of the relationship type. In the previous figure, we have seen the relationship set, right? And each instance in the set relates individual participating entities, one from each participating entity type. In the ER diagrams, we present the relationship type as follows. Diamond shaped box is used to display a relationship type. And connections are used for expressing the relationship. uh, like here we have connected to the participating entities types via straight line. When we have a relationship between the two entities, we are making use of a straight line which is connecting the two entity types, and we say that there exists a relationship between these two entity types. Now you can see we have many relationship types over here, like um, works for managers, controls, works on supervision, and dependents of. So these are all the examples of the various entity types, I mean the relationship type. Apart from that, we have all are binary relationships. Why we say all are binary relationships is, if we consider works for, we have a relationship between two tables, that is employee and department. Then managers between employee and department. Controls, again it is between department and project. Works on, again it's between employee and project. And supervision, it's between employee and employee table again. But the thing is, uh, we call it as recursive relationship, right? Here we are going to consider employee and employee table again, which we'll be seeing in the subsequent class. What do you mean by recursive relationship? Apart from that, we have dependents of, again, between employee and dependent. Okay, thank you.